Hello Internet, welcome to another tutorial in Digital Electronics series. Today I'll discuss binary to 7 segment encoder. Now this encoder is going to perform the task of illuminating this 7 segment display depending upon the input that we give at ABCD binary input port. Please understand this 7 segment display consists of light emitting diodes in each of its arm. So this is what the actual arrangement of this 7 segment display is. It's a collection of basically light emitting diodes in such a way that they'll illuminate a specific digit depending upon whatever number is inputted, and the connections at the output are made like this. This output is used to drive this LED, then B is used to derive this LED, and similarly C, and all these are connected in such a way that each of these outputs is going to illuminate one arm of the 7 segment display. Now when we need to draw the truth table of this 7 segment encoder, in order to complete this logical circuit, we need to see that 0000 in binary or BCD would represent a decimal number 0 whose shape will be obtained if such a pattern is obtained at the output. If we keep the G LED closed and if we lit up all the other LEDs, then 0 is displayed. So that is how we keep 0 at G. So we do not want any signal going from this output to the array of LEDs, and we make all the other ones 1. So we get a 1 1 1 illuminating everybody else except G will give us a 0. Similarly, you need to populate this entire table up to 9 because it'll work for displays from digits 0 to 9. And similarly, I've made this arrangement for 1 will be illuminated for B and C only, and 2 will be illuminated when A is lit up, B is lit up, G is lit up, E is lit up, and D is lit up. So I put C and F as zeros. Similarly, 3 is lit up only when F and E are zeros. So 3 will be obtained by putting 1s here. 4 will be obtained when E, D and A, E, D and A are zeros. Rest everybody else is 1. 5 is obtained by keeping B and E as 0, and rest all the LEDs need to glow. 6 will keep only B in off position. 7 will turn off F, G, E and D. So 7 will be something like this. 8 will have every LED turned up, and 9 will have just E turned off. right? And for these inputs 10, 11, 12, we get a do not care. We have a relationship of outputs with the inputs. Now we'll need to draw k maps for each of these 7 outputs. So we need to find the output expressions for small a, b, c, d, e, f and g for the inputs capital A, B, C, D. Alright, for example, we need to determine the expression for the output small a, which connects to the LED placed here. We'll put in the outputs in this K map. So for 0 it is 1, for 1 it is 0, for 2, 3 it is 1, 1, 4 is 0, 5, 6, 7, 8, 9, all of them are 1s. And then rest of them are do not care. So we'll see, we'll get a do not care for 6 set of inputs for sure in every case. So my small a becomes the reduction of this K map. So I get this octet, which gives me capital A, plus I get this octet, which gives me C, plus in order to cover this one, I can use these 4. So I get a B and a D, and in order to cover this one, I'll go ahead with this quad. So this will give me A bar, no, this will give me B bar and D bar. Yes. So this becomes the expression for A, and similarly we need to find the expression for B, C, D, E, F and G. I'll make a separate video if you wish to see the solution of all the K maps for all the 7 inputs. You can see that video, but the purpose of this video was to introduce you to this encoder so that you can get the output expressions in terms of inputs. If you need to design the logic circuit, this black box, what's inside the black box, or if you need to write the VHDL program. And I hope this tutorial was of help. If you like the content, give it a thumbs up, consider subscribing to the channel. I'll see you in the next one. Goodbye.